disintegrating and rematerializing at the touch of a button, crossing thousands of miles of space on a beam of X-rays. Teleportation is the only way to travel, and it could be coming to a planet near you. I'm Dr. Michio Kaku. I'm a theoretical physicist and a science fiction fan. Join me as I show you how to make sci-fi science. Imagine a future where teleportation is possible. In the time it takes to make a long-distance phone call, you could be there. If an alien invasion force was hovering overhead, or an asteroid was hurtling towards the planet, you could instantly beam yourself out of danger. Cars would be obsolete. Airline food, a bad memory. Even NASA engineers could put their feet up. Who needs expensive rockets when you could simply teleport? I could zap to Paris on a whim, swing by Tokyo on the way home, and take in the view from the moon if I felt like it. A teleportation system would change everything. And I'm going to show you how to build one. I want my design to be the ultimate sci-fi teleporter. First, I need a very clear design spec. Who better to ask than the sci-fi fans themselves?
A teleporter should be able to just put you anywhere.
Like a doorway that you're walking from one location to another.
You would be able to step off of the platform here on Earth, and suddenly you're now climbing the mountains of Mars.
My teleporter needs to provide instant travel to anywhere over any distance. I guess Mars could become a hot holiday destination. For those of us without the power to jump through space-time, teleportation is going to require some pretty serious equipment. My system needs to be fast, accurate, and 100% painless. It should be able to beam you anywhere, instantly. It has to be totally reliable. Who wants to teleport if there's a risk of losing half your body in transit? My teleporter should be able to transport anything. A person, a train, the Empire State Building, if it fits into the machine. Let's say I want to send this sculpture to the International Space Station. According to the lore of science fiction, I've got two options. I could break it down to its atoms and somehow try to transport those, like in the movie The Fly. But I think Star Trek had a better approach. Convert it into data, a bit like a set of instructions, and beam those up. This may sound pretty simple, but it helps to bring teleportation one step closer to reality. Rather than transport the atoms, I transport the instructions. And providing that there are plenty of atoms at its destination, it can be reassembled. Data contains no matter, so it would be a lot easier to beam around the universe than solid atoms. This is definitely the best option for my design. And the crazy thing is, I've been beaten to it. Scientists here at the Joint Quantum Institute have achieved the impossible.
That event, the rising edge or falling edge, tells us that the teleportation is done.
Chris Monroe and his team have already managed to teleport atomic data. So we're actually witnessing teleportation right there and right there.
That's right. That's happened a few seconds ago.
So teleportation really is possible. This is proof of principle. Chris and his team have teleported atoms using nothing but a mysterious connection called quantum entanglement.
Quantum entanglement is a link that allows you to transfer information. It's very much like a cable, but the cable's not there.
I think this invisible cable could be the basis for my teleportation system. In this experiment, two metal atoms are enclosed in separate containers. We start with two laser pulses that vibrate exactly in sync. Those two pulses in turn hit two atoms simultaneously, so the atoms too are now vibrating in sync. This somehow creates an invisible connection between the two atoms.
We form the link using light, but after the light is gone, the entanglement is still there. So what makes the entanglement? There's not a good answer, because there's nothing that makes the entanglement. It just is.
It's so weird that even Einstein had problems understanding what was going on. He called it spooky action at a distance. Imagine all the information in atom A magically teleported across the room to atom B, creating an exact copy of the original. All that we used was this ghost-like bond between two atoms called quantum entanglement. It actually blows my mind. Just imagine, the universe is crisscrossed with trillions of these weird wires, each one carrying messages between distant atoms. Hi, I'd like 2 plain hot dogs, please. Quantum entanglement is on the very edge of our understanding of the universe, but it seems to work like this. If I bite into this hot dog, then I know with 100% certainty that nothing will happen to that hot dog. However, if these hot dogs were atoms, then the laws of quantum physics apply. And in the quantum world, things get really, really weird. Let's say these atoms could be in one of 2 quantum states, mustard or ketchup. In the quantum world, until the moment I try to find out what state the atom is in, it's constantly switching between the 2. It's only when I look closely that the atom picks which one it will become. But here's what's even stranger. If I manage to entangle the 2 atoms, then the moment one hot dog becomes mustard, its partner, even if it's at the other end of the universe, mysteriously becomes ketchup. If the first hot dog picks ketchup, then its partner becomes mustard. This invisible entanglement link could be the key to my teleporter design. It's the pipeline through which I can transmit data. How can the information of one atom move to another atom across light years of space? What is this invisible bond made of? The short answer is, we have no idea. Let's say I wanted to teleport an atom from here to Tokyo using quantum entanglement. I start with 2 atoms that are vibrating exactly in sync, so they become entangled. Then I separate them, putting one in New York and the other in Tokyo. They would form an invisible cable along which data about my atom could travel. Next, I would take the entangled atom in New York and turn it into an exact copy of my atom. Because of the weird laws of quantum physics, the atom in Tokyo instantly becomes a mirror image of my atom in New York. If I make a measurement of my New York atom and find out it's red, then I know that the Tokyo atom is yellow. So by simply turning the atom in Tokyo into its opposite, I find that it's now identical to my atom back in New York. Faster than you can say energize, all the information in my atom in New York has teleported across the planet to Tokyo. So in theory, teleporting a human should simply be a question of scaling things up. But I would need an entangled atom for every atom in my body. But that's 2 whole bodies worth of atoms. I need a pile at every conceivable starting point and destination. And entangling atoms is not exactly easy. It takes the team at the Joint Quantum Institute in Maryland 45 million attempts to entangle just 2 atoms. So it would be unbelievably complex to build a machine capable of entangling every atom in a human body, every single time you wanted to teleport. There are more atoms in a human body than there are stars in the visible universe. So to teleport a human being using quantum entanglement, that gives me a headache. Quantum teleportation transfers information rather than solid atoms. I still think that's the key to pulling this off. But you know, I simply don't trust quantum entanglement to teleport the atoms of my body because it's so bizarre and poorly understood. To make teleportation a reality, I want something reliable, something tried and true, rather than such a strange phenomenon of the quantum world. I need to find a radical new way to teleport information. I'm designing the future of transportation, a teleporter. As any sentient being knows, teleportation is the only way to travel. But is it actually possible? Single-atom teleporters have been made in the laboratory. Pretty mind-bending, but they're not going to be beaming me to Mars anytime soon.
Stand by.
To be practical, the design needs to be based on solid science. I mean, who's going to hop into an unreliable teleporter? Even science fiction fans have their reservations.
Dying is a major risk in teleportation, I would say. A risk of you just never rematerializing. That'd be sad.
I probably wouldn't be the test dummy for anything that could potentially get me to not exist anymore.
They're right. My design must be safe. Transporting the actual atoms is just too dangerous. The Star Trek transporter had an energizer coil to emit waves of energy that analyzed the body. They were definitely onto something. I really believe the key is to turn the body into data and have it rebuilt at its destination. In 1974, Dr. Raymond Damadian invented something totally ahead of its time, the MRI scanner that extracts data from the human body. His machine could form an excellent base for a teleporter.
I'm now inside an upright MRI machine. I'm surrounded by a magnetic field 12,000 times more powerful than the Earth's. This is the key to peering inside living tissue.
As the scans turned on, I'm immersed in radio waves which push and pull at my atoms, making them send out tiny pulses of energy used to generate detailed images of my body.
This is what we would traditionally call a multi-slice image through the skull and neck.
An MRI image is like a map. The map is made of pixels, and each pixel reveals the position and properties of tiny groups of cells.
The side of each one of these pixels can be, with our current technology, of the order of 1/4 of a millimeter on each side.
The smaller the pixels, the more precise the map. This machine has pixels which are smaller than a single pinhead. But for my teleporter, I'll need an image where each pixel is the size of an individual atom.
The big limitation at the moment is the uniformity of the magnetic field.
To get atom-sized pixels, we need to direct these powerful magnets equally over the whole body.
So if we can make that magnetic field more uniform, the smaller those pixels can be.
The technology behind the modern MRI scanner is perfect for my teleportation system. With bigger magnets spread evenly over your body and higher resolution sensors, an advanced MRI should one day be able to generate an atomic map of a human body. The first stage in my teleporter design is a scanning platform set within a ring of powerful electromagnets. To pinpoint individual atoms, it needs a field many thousands of times greater than the Earth's. Just like Scotty's design, my teleporter will have an overhead device producing pulsating radio waves to turn atoms into data. The machine could accurately scan my body down to the atomic level and turn it into data, but it's a lot of data. I'm going to assume that in the future, one atom could be described by one computer bit, a single 0 or 1. A standard DVD can hold 40 billion bits, but that means to hold the atomic map of a single human, I need enough disks to hold 35,000 billion gigabytes. That would completely fill 3,978 Empire State Buildings. How on earth am I going to transmit all that?
I'm designing a teleporter.
Using the science behind the MRI machine, I could turn a human body into pure data. But getting all that information to its destination is not going to be so easy.
Data is sent around the world along thousands of miles of this stuff. These are optical fibers. Each cable contains a steady stream of digital zeros and ones, created by chopping laser pulses into tiny bits.
Light is made out of photons, which move through the air and optical fibers in waves. Each cycle of the wave, up and down, can carry a single bit of information. So the smaller the wavelength and the faster it vibrates, the more data can be packed onto a beam. Laser light cycles up and down over 1 trillion times a second, so it can carry a lot of data. But even with 1 million beams, it would take a year to transport a human being's data. It would be faster to walk. My teleporter will beam a set of instructions so that my body can be rebuilt at its destination. But to pull its weight as a genuine means of transportation, I need a way to transport those instructions extremely fast.
Carrying information aboard beams of light is not going to work for my teleportation design. There's simply too much data. I need something that vibrates even faster. And the answer is X-rays.
They have a shorter wavelength than light waves, so I can pack 1,000,000 times more data onto each beam. Even so, to get the transfer down to a second, I'll need 100 million X-rays. That would make a huge beam many feet across. But unlike light, I couldn't pass the X-rays down optical fibers. They're so powerful, they could leak out. I need to send the X-rays up into space, where a network of satellites will direct the beam to its destination. But that's where the next problem starts. How will I turn all this data back into a human being? Get more sci-fi science online. I believe teleportation is possible, but I've got one major problem to solve: how to turn a staggering amount of pure data into a living, breathing person. With just a stockpile of atoms and a set of digital instructions, my teleporter machine should be able to fabricate any object. Something like the replicator from Star Trek would do the trick. A machine as advanced as that is maybe only a century or so away. Futurologist Mike Schroeder is already thinking about how it might work.
Whether you call it a nanofactory, a replicator, or a fabricator, could have different names. The idea is they'll be able to assemble things atom by atom with molecular precision. It seems almost certain they'll be able to create complete living organisms at some point in the future, although it's very challenging.
We could get an idea of how this might work by looking at one of today's state-of-the-art 3D printers. First, the object to be assembled is scanned, creating a 3D digital image. The system then breaks this complex data into simple 2D slices, which it sends to the replicator-style assembly machine. The device fabricates an almost exact likeness of the object layer by layer with almost surgical precision.
Now, this machine obviously has not created an exact copy of me. This is just a three-dimensional reproduction of my face. Think of it as a 3D photograph. But in the future, using similar principles, it should be possible to create a living, breathing copy.
Using cutting-edge science and a little bit of science fiction, I think I've got the design for a truly awesome teleporter. I wonder what the sci-fi fans will think of it. Today, I'm going to present to you the first workable design for a transporter. And we're going to answer the question, when are we going to be able to zap our molecules into outer space? The world's first teleportation passenger steps into the scanner. It's made of non-magnetic materials to resist the powerful magnets. Now, pulsating radio waves start the job of converting atoms into pure data. 35,000 billion gigabytes of it. I need to transport that mountain of data to its destination. You have about 10 to the 25 atoms inside your body. Now, an ordinary laser beam cannot carry that amount of information. Instead, I pack the data onto a beam of X-rays many feet thick and fire it straight as an arrow up to a geostationary satellite above the Earth. It would be possible for someone to intercept this beam and make an unauthorized copy of the person. So I've added an encryption device to keep the data secure. Next, the beam is sent hurtling at a fabricator station on the other side of the planet. The data arrives, and an advanced quantum computer starts the billions of computations necessary to open up the instructions. It has to be received by a computer that can handle this vast amount of information. Now the data's unraveled, a molecular assembly machine begins to piece everything together. The scanner opens, and an absolutely perfect copy of our teleportation pioneer steps out, safe and sound. But this leaves us with one remaining problem that could inspire a science fiction movie all of its own. The body at the departure point is still there. He was only scanned, he wasn't dissolved. Things could get complicated if teleportation really takes off. Luckily, we've got a while to iron out that little wrinkle. So there you have it. In the next few hundred years, we'll be zapping our molecules through space.
It's really interesting. I really do see it happening.
We're going to see it sooner than we think.
Volunteer. If I can interview my double before they kill me, yeah, I would.
Once it was perfected, I would definitely jump on board.
It'd be nice to have a spare of me hanging around, but I don't know, I think one of me is enough.
That sounds like a risky business to me. I'd certainly want to be under a sedative.
I'd love to try it. I'm the laziest traveler.
Could it work? Yeah.